Earth science: how did Pangea form and break apart? Imagine a time when all the continents on Earth were joined together like a giant puzzle. That supercontinent was called Pangea, and its story is a fascinating chapter in Earth's history. About 335 million years ago, during the late Carboniferous period, smaller landmasses started to come together. These included Gondwana, which would become Africa, South America, Antarctica, Australia, and India, along with Euramerica and Siberia. Over millions of years, these pieces collided and merged, forming a massive landmass surrounded by a vast ocean called Panthalassa. The collision created huge mountain ranges like the central Pangean Mountains, which stretched across the supercontinent. But Pangea did not stay intact forever. Around 225 to 200 million years ago, it began to break apart. This process did not happen all at once but in stages, driven by what scientists call plate tectonics. The Earth's outer shell, called the lithosphere, is made up of large rigid plates that float on a softer layer underneath called the asthenosphere. These plates are always moving, sometimes pulling apart, crashing together, or sliding past each other. The first signs of Pangea breaking apart appeared in the central Atlantic region. Rifts formed, and new oceans started to open up. The first was the Central Atlantic Ocean, which grew between North America and northwestern Africa. Soon after, the southwestern Indian Ocean opened as Africa separated from Antarctica and Australia. About 140 million years ago, the South Atlantic Ocean started to form when South America pulled away from Africa. Later, around 80 million years ago, North America separated from Europe, and Australia began to drift away from Antarctica. India also broke free from Madagascar and eventually collided with Eurasia about 50 million years ago, creating the Himalayas. These movements are still happening today, slowly reshaping Earth's surface. Scientists have found clues that support this story. For example, coastlines of continents like South America and Africa fit together like pieces of a puzzle. Rocks of the same age and type are found on different continents, and fossils of the same species appear on now distant lands. These pieces of evidence helped scientists develop the theory of plate tectonics, which explains how Earth's continents move. Understanding how Pangea formed and broke apart helps us see how Earth's surface has changed over millions of years. It explains why continents are where they are now and why mountain ranges and oceans exist. This discovery was a major step forward in Earth science because it showed that our planet is constantly changing, not static. It also helps scientists predict future movements of Earth's plates and understand the history of our planet better.